Do you have an old alternator that you'd like to test? Just kick around the shop. Here, I'll show you how to do it. Okay, so what we got here is an AD244 alternator. Came on 99 to 2006 GMC trucks. This great alternator rated 140 amps. The key thing about this alternator is that it gives you most of all your current at idle speed. So you don't have to rev the alternator or your engine up to 3000 to make a lot of current. So all you need to test the alternator, so I got the plug here, factory plug. It's a 4-pin plug, only 3 of them are used. The only one you need to worry about is the brown wire. So this plug, essentially there's letters associated to the plug ports. So you got PLIS. So P will be for, it's mostly used on diesels. It'll be essentially a rev counter. So this is how your diesel vehicle tachometer is hooked up. It's hooked up through this wire. This came off a gas motor, so this wire wasn't used. This here is the L. It's for the lamp, so your charging indicator dummy lamp. This wire is for. PLI. This will be usually an ignition wire. So hooked up to 12 volts, mostly in the pulse width modulation newer trucks where the ECU controls the field of current. This wire will be used. This wire here, actually GM didn't use it. It's the S wire, sensing wire. So if you want to account for voltage drop, you would run a wire here to wherever your voltage really matters, and then that'll account for the voltage drop. So the only wire you're concerned about is the brown wire here. That'll be the lamp wire. This is the only hookup you need to test the alternator. So I got my voltage meter here hooked up to the battery. We'll turn it on. Okay, so we're at 12.53 volts. I'll just put it here so you guys could see. Okay, 12.53 volts. Now, I've got a light bulb here, so get yourself a little 5-watt light bulb. Run a jumper wire from the brown wire to one side of the light bulb. The other jumper wire, I got going to the switch. This is just for, so that I could control when it's going to charge or not, but you don't need to hook it up to the switch. And then go to the positive post on the alternator. Do not hook this wire up to the positive post directly without a load, because you will fry the voltage regulator. It needs to have a load on it, or in series with it. Okay, so get yourself a drill with I got a 31/32 socket on here. So right now I got my switch off, so it's not going to charge when I spin the pulley here. So we're at 12.53 volts. So I'm going to start spinning the pulley. Nothing's changing. Okay, so now I'm going to flick my switch. Okay, so this is your dummy light. So this is telling you the alternator is not charging. Now you'll notice as I start turning this pulley, that light will go dim until it's all the way out, and that's when it'll start charging. So let's try it here. Okay, I'm not spinning it fast enough. Let me kick it in second gear here. Okay, I'm not able to spin it fast enough. Let me get another battery. You You need to be spinning this pulley at least 1500 RPM, so we may have a hard time. But we're at 12.3 volts. We'll turn our switch on. There we go. So battery's at 12.10 or 2. So we'll start spinning it. Not charging, not charging. You'll notice if I release the trigger, the light will come back on, saying it's not charging. Now if I turn that switch off, listen for the speed of the motor on the drill here. It'll really slow down once I flick this switch at high speed, showing that the alternator is putting a load on the drill, because it's actually creating current, generating current. So that's full power on the drill. I'll flick the switch. It's really giving her now. Flick the switch. No longer charging. Drill's going at full speed. Okay, so that's essentially how you test the alternator. Like I say, all you need is one wire. The brown wire, well, GM uses brown, but it's essentially the L wire, which is light, indicator light. So take a jumper from that wire, go to your bulb. Again, make sure you got, if you don't have a bulb, get at least a 50 ohm resistor. Put it in series with these two jumpers. Otherwise, like I say, you'll fry the voltage regulator. So the other end of the bulb, in my case, goes to a switch, but that's not necessary. The other end of the bulb will go to your positive ignition source. Now these newer GMs, they don't have a incandescent bulb. They actually have, this goes to a computer, so the computer will ground this bulb on your dash, telling you that you're not charging, but they use pulse width modulation through this wire here. So that's essentially sine waves, and that'll regulate the field of current that this alternator will output. But on an older truck, like say a 98 or whatever, then all you need to run this alternator again is this one brown wire. One more thing I wanted to touch on that I forgot to mention is these newer trucks like the GMT 900 platform, 2011 and up and stuff, they really use that pulse width modulation to actually vary the voltage output of the alternator. So at idle they'll output maybe 13.2 volts just so they don't put a huge load on the motor, and on highway or whatever they'll output, I think it's even 12.8 volts or something. It's very low. Now this is okay for the average user, but if you're running car audio and stuff, you're not gonna like this. So what I've heard is this pulse width modulation wire, if it senses an open, so if you cut this wire, the alternator will run full field, so it'll default to its 14.5 volts. So that's very common in the car audio department. If you're, like I say, if you're running subs and stuff, you don't want that 12.8 volts going to your subs. Cut this wire, you should have 14.5 volts all the time. So I got a different battery hooked up now. The other one was dead, which is probably why it didn't want to charge all that good. So let's just do a quick, we'll turn it again and see how many volts we could get. Turn the bulb on. Okay, so 12.7 volts. And say your belt started slipping, then your light would come on. There she goes. Yeah, so that other battery was just straight dead. So that's why it was taking up so much current that I couldn't spin the alternator fast enough to get some current flowing there while maintaining the voltage. So there you go, we got 14 volts out of her. Again, I'm probably not spinning it quite fast enough, but if I had it on the car, it would spin much faster. Again, hope you guys enjoy this video, and